And once it was calibrated, it was ready. So it's understanding what is going on, how it is reading, it's actually going through. Yes, there is a wonderful connection between satellite and drone. Mr. Suresh, please.
See, this system that you see here can be imagined as a satellite. Okay, I'll tell you how. See, it has DC motors, okay, which we'll talk just in the next slide, how a DC motor can be used to stabilize. Our friends will show you how he will stabilize this drone using this DC motor. That is one thing. Second thing is, this, when it moves like this, right? A satellite will also move, right? Just imagine it like a satellite. It will be a real good thing. When it moves like this, there is a gyroscope inside, which tells you at what rate of angular velocity it is moving in this direction. I told tumbling, right? You remember? So tumbling is something like this. I don't know whether our friends can create that scenario. Like this, the gyroscope is a 3-axis gyroscope. Okay, and that data is actually given to the onboard microcontroller, which is a 32-bit ARM microcontroller. Just everything that we saw, please relate. That is given there. And what was the actuator in our theory, which we were discussing? DC motors, right? DC motor also. This fellow has DC motors, whatever. So whatever it is. Basically the RPM should be controlled.
The same DCs, brushless.
Brushless DC motor, very good. So see, exactly everything matches.
Even the body, the framework, everything is of a unique, special materials over here.
Okay. So, at every instant, when our friends will drive this or fly this drone, the instantaneous angular velocity we saw in our block diagram, the sensors given to the microcontroller. Microcontroller runs an algorithm. PID can run in this, because I've seen in our institute where my friends were researching on drones, developing control algorithms, he said his drone has a PID control.
Yes.
So for the time being, imagine, it may have, this is a very complex machine. Actually it does a lot of research. But it works, because I've seen a drone working in IIT Madras based on a PID controller. Just imagine all these things which we saw. Now, what they will do is, let it be like this, which is a satellite thrown in air, which is in tumbling position. He will. It is possible. I think they can demonstrate that.
Wind currents and those particular things are the most important factors to be considered.
Very true.
When there is a wind that is blowing an opposite angle, what it has to do? It is going to lift off like this, right? It is going to drift away. From drifting, what it has to do? It has to reduce the speed of this, propellers and increase this propellers to again come to a stable position, right? The same thing happens. That's what exactly the things will work.
But the best part in satellite is, there's no air there.
Absolutely.
So you may say that it's much simpler. Yeah, because you don't have the air drag, that is called as drag. Here there is a drag. So this is a more complex system than a satellite, I will say. Actually not, because there's a lot of space grade testing that you have to do before you fly it off or put it in the launch vehicle. That's
So how does this drone fly? I fly here. How does it take off? What makes it fly? Thrust?
It's a thrust.
Thrust of what medium?
Air medium.
Super, air. Then what about a satellite? Quiz for you, write it down. The point, Google it.
Okay, so here what they will do is, orientation we can change its motors, right? We'll ask him and we'll show you how this drone, after stabilizing, okay, will rotate like this. A satellite can never become stable, you know? It keeps moving like this. But that is a controlled rotation. We'll request our friends to simulate that. So everything that we read, what we discussed regarding a satellite's attitude control can be mapped one-to-one with this machine. We'll see that now. After that, quickly, we'll see the theory behind it. That is the next part. So you'll be able to relate very clearly the practical system and the theory that you read in the class. Let's have it.
Before switching on this drone, I would like